Hello, my name is Shevchenko and I'm the CTO of Crocoblock. At start, I will tell you just a few words about our company in case you don't know who we are. We develop WordPress plugins for various tasks, and our main goal is to create an ecosystem in which the users, with help of our plugins, can create their site from scratch, starting from the website structure to the design of individual pages. We specialize on dynamic content and have developed over 20 plugins that work with Block Editor, Elementor, and Bricks Builder. So let's start. When all the AI excitement started, we also started to work on its implementation into our products. We have identified two priority areas for such AI implementation that will be really useful for our products. The first one is generating new data for the user, and the second one is a processing of existing data. I will elaborate on the second point in a couple of minutes, but for now I will say a few words about the first one. The first direction is generating new data for the user based on the knowledge AI already has. The most recent example that we have already released is SQL queries generation using OpenAI. The user writes in words which data they want to get from the database, and OpenAI writes it in the form of an SQL query. By the way, OpenAI by default is very good at understanding SQL and SQL queries for WordPress as well. So it generates the query for the user, then it gets a little bit adapted from our side and is delivered to the user. In most cases, the result is completely ready to use on the website. We also have several options how to use this approach further, not only for queries, but for some content elements. Also, I would like to pay attention to one more thing using this example. It's user's resistance. After implementing functionality for SQL queries generation, we faced some user's resistance. And I will divide this resistance into three big points. First of all, when we embed a new interface directly into the plugin, users don't really understand why they can't perform the same tasks using ChatGPT. So we have to explain that we have actually done something here, removed extra iterations, made it work faster, and there are other things under the hood. In other words, you can't get exactly the same result just by using ChatGPT. The second point is that the result is not so accurate. Even though AI is quite good in SQL, it's very important what you ask and how. For example, while developing this feature, I tested a ton of prompts and only around 80% of the answers were correct. But if you refine the prompt, the chance of getting the correct answer is very high. But the real problem here is that to know what to refine and clarify, you have to know SQL for yourself. And the third one is you would better to do something else instead of adding such a small piece of functionality that just speed up one thing. So when you start your AI experiments, you need to be ready for this resistance. At the moment, let's stop on this, and I think we can dive deeper some other time, for example, during another conference. And now let's talk about the main topic today: processing of existing data by AI. Here I'm talking about some data that AI receives from our site, handles it in some way, and after that can give users the answers to their questions based on that data. Initially, we needed this functionality to improve user interaction with our knowledge base. But the same problem is relatable to any WordPress website owner, because in most cases the default WordPress search is not enough for the user to effectively interact with the content of your site. From this comes the idea that you can train the AI using the content of your website, and after that, AI will interact with the user based on your content knowledge. This process can be implemented in the form of a chatbot or in the form of an improved search on the website. The first one is more complicated, so we have started from the second, the search. So now I will tell you about our process and results in more detail. First, we have analyzed which existing solutions OpenAI offers for such tasks. The first thing we tried was fine-tuning, and according to the description, it looks like very close to what we need. It works like this. You choose a base model, train it on your set of prompts and completions, and after that, this trained model is supposed to answer the user's requests. But there are a big problem here. OpenAI doesn't memorize the data you give it with prompts and completions. Fine-tuning just helps selected and pre-trained AI models to perform specific tasks more accurately. For example, you can train the OpenAI model to classify the information or boil down to one word, or set in the style, tone, format, and other aspects of answers. So you give a big set of predefined prompts and completions, the model gets trained and then is able to perform classifying or other similar tasks. That's why the fine-tuning didn't work for us in this case. The second tool is Embeddings API, and this is what works for us and is actually created for such tasks. Embeddings is also a part of OpenAI ecosystem, which allows you to analyze the text that you give it and generate a vector presentation of this text, which is a sequence of numbers. So we can give this API a large volume of information, get its representation in vector format, save it, and then compare saved vectors with user requests. This was a general explanation, and now I will break it down into the points and tell you what exactly we have done and how this logic works. So we have a WordPress website. First, we split all the website content into fragments. After that, using Embeddings API, we convert these fragments into vectors. Then we save the vectors in the separate database table at this website. The next step is to create a search interface for the user, or just use the default WordPress search form. In the next step, we are using Embeddings API again to convert the user's search request from this form into a vector. And finally, we compare the user's request vector with the existing vectors of the content fragments stored in our database. At this point, we sort all these fragments using mathematical methods to find vectors most similar to the user's request vector. I will give the links to these methods at the last slide of the presentation. The most similar vectors will be the text fragments that are the most relevant to the user's request. All that remains is to turn back the found data in some way, for example by hooking into the default search query. And it's all. We get the relevant website search functionality that works on the basis of AI. Now, let's name the advantages of such an AI-powered search compared to the standard WordPress search. First is the accuracy of results, and the second is insensitivity to spelling, which means that by default, spelling mistakes don't affect search results. In contrast, the default WordPress search uses word-for-word method. It tries to find the exact match of the search phrase in the website content. It means that if you make the slightest spelling mistake in one of the words, you will get 0 results. And at this point, I will show you some examples. On this slide, you can see our default search form made for our help center. It uses plain WordPress search logic, and I have entered my search phrase with a mistake, fields instead of fields. As you can see, no results were found. On the next slide, you can see the same form, but with AI search based on the logic I have described. And it has found quite relevant results for the same search phrase. Now let's see the result for a default WordPress search without a mistake. So, also nothing, but even if it found something, it will be just words in the content without the usage context. That's why I would like to pay attention on the fact that the results of the default WordPress search for the request without the mistakes are worse than when using an AI-powered search with mistake. And now let's take a look at the AI-powered search results without a mistake. It gave the same result as with a mistake. So, as I said before, the big advantage is that AI-powered search is not sensitive to spelling. Plus, results are quite close to understanding context of the question. It may seem like everything is perfect, but there are also some drawbacks. And they are actually a reason why it's still an experiment for us. First, it's a speed on large volumes of data. And if during my explanation of how it works you thought that, well, what if I have tens of thousands of such fragments and every time they should be compared and so on, you're absolutely right. PHP is not well adapted for such tasks, especially in combination with MySQL. Also, the problem is that Embeddings API generates quite large vectors, more than 1,000 numbers in one vector. So if there is not much of content, it works with a normal speed equal to standard WordPress search speed. But on large volumes of content, it slows down exponentially. The second problem comes from the first, again, because of PHP, and it performs all action using one request to the server. The longer it processes the request, the more resources it needs to complete it. That's why we can't just release this functionality and give it to any client with any server and any volume of content, because it will not work equally well, and in some cases, for huge databases, it might not work at all if there are not enough resources. And the last problem is not connected to resources, but it's about the logic itself. To get relevant results, you should break content into fragments properly. And I'm talking about both fragment size and the contents or meaning. The fragment should not be too long for better matching short users' requests. At the same time, if the fragments are too small, they might lose any meaning. And the search results will not be relevant because they will not reflect the meaning, but just match a set of letters. And there are potential solutions for these problems, at least in theory. I'm talking about creating the product ready to be used by clients. To make it possible, we have to sacrifice something. So the first solution is using not Embeddings API by OpenAI, but another model that does the same thing but generates smaller vectors. So it would need less resources and will be processed faster. But the accuracy will be lower because the smaller the vector, the higher the chance of matching the search request accidentally. The second solution is moving to the SaaS model, where data storage and request processing will be carried out by more suitable tools, while the web interface works as an API for indexing site content and searching for that indexed content. We will get the same results, but faster and by using less resources on the user side. In this case, we will have a commercial product ready to be sold to clients. For now, as I said before, it's only an experiment, which I hope we will be able to release as a stable product someday. That's it, and here I will add some links. The first is an article by the developer who shares his experience with the Embeddings API. The second is a link to the official documentation on the Embeddings API, and the third link leads to our experimental plugin, which works according to the described logic. This is a working plugin suitable for any site and integrates with any WordPress search. Only downside is that it has all the disadvantages of this algorithm that I have described before. Therefore, you can use it on live websites, but after testing and making sure that it can cope with your data volume. And thank you for your attention. Goodbye.